Okay, so we're going to actually do some math. Yay! We're going to do, I know, measures of central tendency in this chapter, which is a lovely long name for things that you still have done since 7th grade. I mean, we won't get out of 7th grade until after next chapter, chapter 5. We're still doing 7th grade stuff in chapter 4, but this is fun. All right, first thing I need you to go over before we get to the math part is two different words that you're going to see in this chapter, okay? There's a word called statistic, and then there's another word called parameter, okay? Pretty much they're the same, but yet they are kind of different, okay? So a statistic measures, they are measures by obtaining data values from a sample. Okay, so your statistic could be a mean, your statistic could be a standard deviation, your statistic could be a proportion. Again, all these words are probably maybe new for you except the first one. Those are all obtained from a sample. Statistic, obtained from a sample, okay? But again, it could be a sample mean, it could be a standard deviation, it could be a proportion. These are all statistics. Parameter are measures by obtaining data values from a population. Okay? And again, these are also going to be mean. These are also going to be standard deviation. They're going to be the same thing. So then what's the difference, Mrs. Seta? Well, your sample is obviously going to be smaller. You're only going to have a sample of maybe 100 things, whereas your parameter would be referring to the entire population. So that's a lot of more things, okay? Now, here's the other difference between the two of them. Not that there really is that much of a difference, is the parameter always uses Greek symbols. So you're going to see a lot of these new Greek symbols. Don't freak out by them. You just need to interpret them. If you can interpret that that symbol means mean. Oh, that symbol means standard deviation. You'll be fine. But that's all it is. If it has a Greek symbol, it's referring to the population. If it doesn't have a Greek symbol, it's referring to a sample. So get that little bit in your head. Sample, statistic, population, parameter. Okay? Don't freak out by these words. They're just there for fun. All right, so let's talk about our first measure of central tendency. It's called the mean. You know what the mean is. The mean is mean. Okay, mean is your arithmetic average, or arithmetic, however people say it. Your mean in a statistic, in a sample, is written like this, X bar. X bar. That is your sample mean. So if I were to take the average grade in this class right now, I would put X bar as my sample mean. Okay, that's my statistic. My parameter is written like this. It uses lowercase mu. This is mu. It looks like a U with an extra tail. It's called mu, mu. This is the population's mean. Okay, what's the difference? Nothing really, except this was obviously a larger group right here, the population. If I said, okay, I took the sample of chapter 2 test for my class, I would put X bar. But if I knew the sample of every person in the whole entire America who just took chapter 2 test, then I'd put mu. Okay, it's only the difference. It's the same thing, just with symbols. Okay, so you're going to have to, on homework tonight, you're going to be given data. It's going to be great. You're going to be like, I love this. This is from 9th grade. And you're going to have to, whoa, that's not an extra 0. Ignore it. And you're going to have to find the mean. Anybody know what they have to do here? We don't have to organize the numbers when we have mean. Good try, though. Yeah, that's another thing. Just add them up, divide by 5, okay? So find the total would be 445. So it would be total over the what we call frequency, since there's 5 of them. And then just divide that out, and I believe you get 89. Yep. Okay, and that would be your mean. Let's do another one. They've done this one on SATs before. I don't know if you're still going to take the SATs, if you even care about it. Okay, but NHS needs a 95 average. Didn't know if you know that to be an NHS. Okay. Joe's 3/4 grades are 94,
About you, Joe.
97. Yeah, should have chosen a different name. And 89. What does he need to get 97? Does he need, or to 95, sorry, to get 95. Okay. So you need a 95 average. Joe's got a 94, a 97, and an 89. What does he need to get that 95? Okay, so let me show you how to do this, because I don't know why this struggles for people at this time. I mean, this is actually how you should figure out your grades and not have to take a final exam also, okay? But you would agree that there are 4 grades that he's going to need. Would you agree?
Yeah.
And we already know 3 of them? Yes?
Yes.
Okay, so we know we have a 94, a 97, and an 89, and we need to know this grade right here. And what do we do to find average again? We add them up, right? And then after we add it up, we get a total. Listen to what I'm saying. I know it seems silly, but just write what I have. We get a total. And then what do we do with that total? We divide by what? How many there are. Well, there's going to be 4, right? There's going to be 4. So when I divide by 4, what do I want that average to be? According to NHS, it has to be a what? 95. Okay. So again, I know this seems silly, but this is actually going to help you. You have 4 grades. You know that you're going to get a total. You know that when you divide by 4, because there's 4 of them, you want a 95. Well, what would that total have to be then? How would I get that total amount?
Multiply 95 by 4.
Exactly. Work backwards. If you multiply 95 by 4, you know what the total needs to be. It needs to be 380. 95 times 4 would be 380. So then now I could figure out what that grade is, because I already know the 3 here. Right? 94 plus 97 plus 89 is 280. So 280 plus X, I know I'm making this an algebra problem, but that's how I can do it. What does he need then? He needs 100. Okay? He ain't getting in the NHS. No, just kidding. It's called. True. All right. And now a mean of what's called a grouped data. This is a little bit harder. You need to kind of write this down. Find the mean of the grouped data for salaries of CEO. Okay. And they are going to give you, they're going to give you a class boundaries. So 15.5 to 20.5, 20.5 to 25.5. 25.5 to 30.5. I'm doing 2 more. 30.5 to 35.5, and then 35.5 to 40.5. They're also going to give you a frequency. 13.6411. Okay? And you're going to be asked to find the mean of this group data for salaries of CEO. Okay, let's talk about this because I think people don't understand what the table is that they just gave you. What does 13 mean in this boundary? Think about what we were just doing in the last chapter. What does that 13 mean? You have what? 13 what? CEOs that are getting between 15 million and 20 million or whatever. Okay, I'm going to go with millions. I don't know what it is. What does this 6 mean? You have 6 CEOs getting between here. Would you agree? Do I know exactly what they're getting? No. So I have to do what's called a grouped data for the salaries. So what that means is you actually do what we were doing in the last chapter where we found the midpoints and we take the average of those midpoints. That's really what we're doing, okay? So find the midpoints. Do you remember how to find midpoints of that? What do I do here? Add them up and divide. 6 divided by 2 is 18. 46 divided by 2 is 23. 56, 28. You could kind of see a pattern right now. What am I going up by every time? 5. I mean, once you get to like 2 or 3, you can kind of see where you're, oh, I don't need to really keep adding the 2 and divide, but you can if you want to. And it's just going up by 5. So this would be 33 and this would be 38. Okay. Now, these are the middles. We have 13 guys getting roughly $18 million. So again, how do I find the average? What do I always have? What do I have to do here? That means I have, if you were to write this out in a long way, you'd have 18 million, 18 million, 18 million, 18 million, 18 million, 18 million. How many times am I going to write 18 million? 13 times. Do you want to do that? No. So you do this. You multiply by the frequency. 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 All right, so let's see what we get. Well, this is 38. This is 33. This is 28 times 4, which is 112. 138. 234. Okay, what am I going to do with that now? Again, remember, we're doing mean. This seems weird, but it's way better than doing like this. It's way better than writing 18, 18, 18, 18, 18, 18, 18, 13 times, yes? Then writing 23, 23, 23, 23. Are you with me on that? Because to find average, you would have to add them all up and then divide, right? All right, so what haven't I done now? What do I have to do with these numbers? Take a wild guess. What do you think we have to do now? We have to add them up. Okay, so total would be, let's see, 234 plus 138. I don't know why I'm the only one with a calculator beside Rachel right in the front. I wish everybody would have a calculator. No worries. I know, I'm doing it all for you. 555. Okay, now that I got my total, what do I divide by? Be careful. The amount of CEOs, which would be the total what? So the total, after you multiply, I'm telling you, you're going to have a problem like this. You need to know how to do it. This is where we get the mathy stuff. Take the midpoints, multiply by the frequency, get this total, and then divide by the total frequency. What is the total frequency? 25. There are 25 CEOs. And that would give me the average, the grouped data average of, what do I have? 22.2 mil. And we would write that as X bar because that is our mean. Now, there is a formula for this. I think the formula looks incredibly difficult to, so I'm just trying to give this to you in a more straightforward pattern. It's not that hard, but don't get caught up in the craziness of it all. All right, just a few more central tendencies that you are familiar with. What's median? Middle number when what? Jonathan had said it before. Middle number when lowest to highest. When your data is written from lowest to highest, I should have said, but I went when lowest to highest data. Okay, you have to put it from low to high, and then you cross off the middle number. What if you get two middle numbers? What do you do there? Do you remember? You just add them up and divide by 2. You just find that middle number. Okay, so you can do that. 3, what's the mode? Mode rhymes with most frequent. Okay, remember, don't put 0. If you put 0, that means that that would be the most number occurring would be 0. If you don't have a mode, you actually write the words no mode. Okay, so if you have no mode, don't ever put a 0. Never put 0 unless that is your data value. You could have bimodal. What does that mean again? Bi means 2. So you could have 2 modes. So like in this class on the test, I did have 2 modes. I had 100 and I had like a 96. Those were the modes that occurred. So I could have 2 modes. That can happen. Okay. For what's the range? You know that one. Highest minus lowest. It's called your range. Anybody have a guess what the mid-range would be? Middle range, mid-range. What do you think you would have to do now? Divided by 2, exactly. You would take your highest minus your lowest and divide by 2. I like when everything kind of makes sense. All right, and then just one thing about distribution shapes, and then I'm actually going to do one of your problems for you. Wow, that's way too nice. And then we'll stop right there, give you a little chance to do this. And then I'm teaching second lesson because there is a 2-lesson day. You didn't get anything yesterday. You lucked out. Right, Keegan? Just have to agree. Distribution shapes. We're going to get into this more often. When we have our bar graph that is beautifully symmetrical like this, okay? We call this a bell curve. Okay, this is symmetric. It's a bell curve. That's what you want, to be honest with you. Almost everything to fall into this beautiful bell curve. Anybody want to take a guess where the mean is located? Where would the mean be located? Take a wild guess. Right in the middle. That's terrible, but it's supposed to be. Guess where the median is located? Right in the middle. Take a guess where the mode is located. Right in the middle. This is where they get the phrase measures of central tendency. If everything is in what's called a bell curve, then everything is symmetrical, then your mean, mode, and median should be right there in the middle. Does that not make sense, right? The mode would be the highest up here. The median should be right there. The mean, the average should be right there. Well, what happens if I skew it? Meaning, what if I draw like this, that kind of skew? By the way, what is this called? Start up here, right skewed. So what happens when I have a right skewed data? Okay. Well, your mean is kind of, here we go. Your mean is kind of pulled down a little bit. Probably be about here. Your median would actually be right about here. And your mode obviously would be here. Okay, so when you're right skewed, it actually just pulls down the mean a little bit to the right more. Okay, and that's why in a right skewed, you actually want to use the median. Anything that's skewed, you actually want to use the median. For example, like, teachers here at Metrolina, how much do we get paid? Okay, it's going to be skewed, obviously, because the longer you're here, the more you make, as opposed to the newbie teachers. So you want to take what's called the median of all of us to give a better estimate. What do you think is going to happen if it's, that was terrible. Why did I draw it all over here? Have no idea. What's going to happen if it's left skewed? Left skewed. It's going to be, yes, exactly the same thing in a opposite direction. So again, ooh, here we go. Your mode would be here, because that's the most frequent. That makes sense, okay? Your mean would be probably about here. And then your median would be here. And that's the issue that you'd want to take. All right, I'm going to do number 24 for you for homework tonight. And you're going to be so thankful because I know that that's the one that you would skip. Right, Jonathan? Yeah. Uh-huh. No, not Keegan. He does all his work. Look at how many stickers that boy has. He's got a lot of stickers. Where is my, there it is. Here we go. And I actually don't like 24. That's why I'm doing it for you. Page 125. Just don't like the way they word it. Number 24, yes. Fat grams. Using a weighted mean. Find the average number of fat grams per or fat per ounce of meat or fish that a person would consume over a 5-day period if he ate these. 3 ounces of shrimp at 3.33 grams per ounce. 3 ounces of veal at 3 grams per ounce. 2 ounces of roast beef, fried chicken, and tuna. Okay, so we're going to find the weighted mean like we just did on that one problem from before. And you can either open your books to that or you can kind of copy down what I have. You can put this at the first page of your homework. You have your homework section out, page 125, number 24. Okay, you can copy this if you want to. If you don't have to, this part. This is fat grams per ounce. So this is 3 ounces of shrimpy. I hate seafood. Disgusts me. I tell Brad all the time, I'm like, I'm like, when he ever eats crabs, I'm like, that's like spiders of the sea. It's disgusting. Crab, no. Shrimp.
No, I like crab. This is amazing. Shrimp's all right. It's got to be like in a dish, though. I can't just eat straight up shrimp.
Really?
I can.
Ugh. Brad eats anything. He likes.
What's it called? Cocktail sauce, and yeah.
He likes escargot and all that. 1.75. He eats calamari. It just disgusts me. Calamari.
I ate sea urchin in Japan and just kind of tasted like.
You know what? I don't know if he ate sea urchin yet. I have to ask him that one. That's the one thing I don't know. He ate eel.
That was pretty not bad.
Disgusting. All right, so let's find this weighted mean. Okay, so it's pretty easy. This is actually really nice because they didn't give us boundaries, so we don't have to find the midpoints. Woo, woo, woo. So what do you think we have to do then? What was the next thing I did on my problem that I showed you? So we don't have to find midpoints. What do we have to then just straight up do? Multiply. Thank God for you, Luke. Just multiply. If you ate 3 ounces of shrimp and each ounce was 3 grams of fat, right? Each ounce, does that seem right? Is there even fat in shrimp?
Yeah, that's what I was about to say. I don't think that's.
That's crazy to me. I thought shrimp is like on the Weight Watcher list of free food.
No.
I only know this because I've been on Weight Watchers my whole life. All right, anyway, we're moving on from this question. 9.99. Yes, darling.
Shrimp have 0.3 grams of fat.
3.3, like, it's just 1 shrimp.
No,
Or
it's
is
still
it-
1 ounce.
That's 3 ounces.
Per ounce. This,
3
according to what my chart says, it's per ounce. That's the amount of fat grams. That's ridiculous. But whatever.
I just looked it up and it said like 0.9 grams of fat per ounce.
Book's line.
Book's lying.
Yep. They don't know their shrimp.
All right, so 3 grams per ounce of veal. We ate 3 ounces of veal, so that would be 9.0. 2.5 fat grams for roast beef. You ate 2 ounces of roast beef. Why does this guy not like roast beef? Whatever. 2.5 ounces of chicken. Yeah, of course, everybody always eats chicken. I love chicken. 4.4, 11.
Tuna's where I draw the line. with
Tuna,
seafood. That's where I draw the
It's
line.
disgusting.
No,
It's just so
actual-
repulsive
Bothered.
smelling.
So
No,
repulsive.
like actual tuna, not like canned tuna. Canned tuna is disgusting.
Okay, what do I do with these numbers now? What am I going to do with them? Add them up, get a total. Okay, so 9.99 plus 9 plus 5 plus 11 plus 7. And I get 41.99. Here's my question, because I have a feeling some of you may get this and some of you might not. What am I going to divide by? What's the frequency that I'm going to divide?
So, hold on.
Total fat.
Total fat or total ounces?
14.5.
Total fat or total ounces? Let's,
This total ounce fat. You get 14.
it's ounces.
Well, that's what we did, it was on the right side.
Yeah, I know, exactly. That's why I don't want you to get caught in how I did it the last time. Oh, it was all on the right side. This one is, again, this is the total grams, right, per ounce that he had. And we want to divide it by the total ounces that he ate, which 3, 6, 8, 12, 14.5, yes. So 41.99 divided by 14.5 ounces would give him he ate about 2.9, right, grams per ounce. 2.9 grams per ounce, which they have in my book. Let's see, 2.896. But, Will debunk that because Will's they did not Google. Their math could even be wrong. If they can't Seriously.
get their shrimp right.
It's ridiculous.